Dear friends, welcome to Infos. Welcome to another video from Oil and Gas Training. Today we are discussing about type of wells. Different type of wells are using for production of hydrocarbon, oil and gas, and in some cases when the reservoir pressure is not sufficient, we are injecting water or gas or various other methods are there producing the hydrocarbon from the reservoir. So type of wells are very important. Welcome to this video. A different type of wells. So generally we can classify in this way. Production wells are there, oil production well and gas production well or hydrocarbon production well. In that one, different classification in advanced level of classifications are there, but here only generally we can speak production wells and injection well. Injection well means we are injecting water or steam or hydrocarbon or nitrogen, etc. to the well again to improve the production, hydrocarbon production. So let us understand the production well and injection well. So in earlier video we have discussed about production well. So this video we are mainly focusing on injection well. So different type of productions are there. One is natural flow. So natural flow means that the reservoir pressure is sufficient to flow the fluid from a reservoir to the surface. So naturally the pressure, high pressure in the downside and atmospheric pressure in the surface. So the flow will be naturally flowing. So there is no need to involve any artificial method or mechanical or other method to improve the reservoir pressure. So other method is artificial lift. As the reservoir pressure is declines to where it can no longer overcome the hydrostatic head of the well, some artificial method to lift the fluid up to the surface is required. So in this case is the reservoir pressure is less or low or it is difficult to develop a natural flow. So here it is mentioned that one difficult to overcome the hydrostatic head of the well. So in that case we are connecting or developing or implementing some artificial method. You can see in this picture it is there one by one. One is a beam pump. This is a beam pump. A pump is using in the surface. A pump is using to surface to lift or injecting high pressure or extra pressure providing to develop a pressure difference, higher pressure difference to lift the oil or hydrocarbon fluid, gas and oil. Next one is electrical submersible pump, ESP pump. This type of pump or this type of pump is a EFC pump. So in generally this picture is providing various artificial lift method. So this also commonly using method ESP and jet pump, gas lift, then hydraulic pump. So here we are going to discuss three different artificial method. One is beam pump, then ESP, then gas lift we are discussing in this video. So natural flow well is already discussed, a well in which the formation pressure is sufficient to produce oil at a commercial rate. So no need any pumping system. So this is a wellhead and well is connected to reservoir naturally flowing. The reservoir pressure is sufficient to flow the fluid from the reservoir to the surface. Natural flowing wells are characterized by a high reservoir pressure in which the fluid contained in their interior reach the surface freely, naturally flowing. So in case the next is important in this this video in the type of well artificial lift. Various artificial lift methods are using to provide more pressure at the bottom of the reservoir and develop or implement that and to increase the production. Artificial lift is a process used on oil wells to increase the pressure within the reservoir and encourage oil to surface. So when the natural drive energy of the reservoir is not strong enough to push oil to the surface, artificial lift is employed to recover more production. So this is a beam pump. A pump, I told you that the pump is using to the surface, and it is the rods and other mechanisms are connected to the down, and which is in fact developing more pressure to the reservoir side. A beam pump is an artificial lift pumping system which uses a type of reciprocating pump. So this is a reciprocating pump to extract oil from an inland well. A nodding donkeys or beam pump are the common artificial lift system used in the land-based operation. The pumping unit drives the sucker rod, which in turn actuates the reciprocating motion of the pump plunger to lift the well fluids to the surface. So this is a simple picture. A mechanical reciprocating pump motor, electrical or power system is there. The power is connected to the pump. So this sucker rod is moving up and down, and this arm is moving up and down, and the connecting rods are moving down and pushing, lifting the oil to the surface. So next one is ESP, electrical submersible pump. In this case, the pump is in the reservoir itself, in the tubing itself. It is downside, not in the surface side. Surface side we have electrical system and a control panel for the pump. So pump is installed inside the well, so far away from the surface. That is here the pump in this location. An electrical submersible pump, abbreviated ESP, is a form of artificial lift that uses an electric motor to drive a multi-stage centrifugal pump to lift the resources from the well. See, so electrical motor is connected to a multi-stage centrifugal pump. In the beam pump, it is a reciprocating pump. Here it is a centrifugal pump, and especially it is a multi-stage. Multi-stage means it can develop more and more pressure. In ESP, an electrical motor and a multi-stage pump run on the production string connected back to a surface control mechanism and a transformer via an electrical cable. So the multi-stage pump and motor is in downside, and all electrical mechanism and the control panel is the surface, and the connection is using a electrical cable. Liquids accelerated by the impeller lose their kinetic energy in the diffuser, where a conversion of kinetic to pressure energy takes place. So converting kinetic energy to pressure energy. So the third one we are discussing is gas lift. So we are injecting gas. You can see here, see the gas is injecting to the annulus, and oil is moving through the production string. See, oil and gas, hydrocarbon is. So gas is in the sideways injecting. Various types are there. Let us see how gas lift is working. Gas lift is a method of artificial lift that uses an external source of high pressure gas for supplementing formation gas to lift the well fluids. So here we are injecting high pressure gas. The principle of gas lift is that gas injected into the tubing reduces the density of the fluid in the tubing, and the bubbles have a scrubbing action of the liquids. So that is the mechanism which is describing how the gas lift system is working. And there are one more terms to understand about gas lift and gas injection. So gas injection is achieved by injecting gas through its own injection well. Gas lift occurs through a production well. So here you can see gas injection well. This is the production well. So both case is different. Gas injection well is in gas lift, compressed gas is injected down to the casing tubing annulus of the production well, entering a well at numerous entry points called gas lift valve. So in gas lift condition, we are injecting the same producing well gas injection through the annulus. But in gas injection, we are injecting a dedicated well which is not a producing well. So it is generally increasing the reservoir pressure in the area itself. That gas is developing that one. So here injection is separate, production is separate. But in gas lift or gas lift method, we are using the same production well. Gas lift and gas injection are both used to increase flow and production from a reservoir. A gas lift is an artificial lift that is a primary method used commonly at all stages of well cycle. So gas lift generally can be used. Gas injections are often referred as a secondary or tertiary enhanced oil recovery method. So this is the main difference. Gas lift generally using to production well directly through the annulus, gas is injecting, that is gas lift. So but gas injections are referred as a enhanced oil recovery method. It is some of the dedicated wells are selecting and then dry gas injecting, compressed dry gas injecting to improve the entire reservoir pressure and producing the oil or increasing the production of oil or maintaining the oil production as target. Some of the we have finished the first part, type of wells and type of production method. So some of the wellhead features in our previous video we have already discussed. Still we have after the wellhead we have some facilities, equipments are there. Let us discuss one by one. The wellhead consists of three components. One is the casing head, the tubing head and Christmas tree. So here this area is Christmas tree and this area is entire area we can call wellhead. The casing head consists of heavy fittings that provide a seal between the casing and surface. So casing and surface, casing is going down and surface is here. The casing head also supports the casing that runs down the well. So all the casing head is entire structural arrangement of the wellhead. And the tubing head is there, tubing head is inside and here the Christmas tree. Christmas tree is the group of valve which is control and maintain and diverting the flow back to production. A wellhead system is a complex assembly of valves, connectors, seals and sensors that must withstand high pressure, temperature and corrosive environment. So that is a wellhead system, and generally we can define is a complex assembly of valves, connectors, many valves are there, connectors are there, then seals are there preventing hydrocarbon leaking to atmosphere, and sensors for temperature, pressure, flow or high pressure or safeguarding. So various sensors we are using that must withstand high pressure, temperature and corrosive environment. The most important benefit of a wellhead is its ability to safely contain the pressure and flow of oil or gas from the well. This is crucial for maintaining the integrity of the well and preventing leaks or blowout. So this is very important. Let us discuss other facilities related to wellhead. Here we are going to discuss on not wellhead, after the wellhead to a production system. Various items are there. Flow line is there, choke valve is there, manifold is there, safety relief valve is there. So let us discuss on that one. Number one is choke valve in this figure. Here the wellhead. This is the wellhead and Christmas tree. So the flow is coming. Some sensors are here. We can assume primarily pressure and temperature sensors. And here the choke valve is coming. So this is after the wellhead. So before the just flow line is starting from this location. Choke valve is a type of control valves, mostly used in oil and gas production wells to control the flow of well fluids being produced. So choke valve is the valve, normally control valve is using, or manual choke valve also can use, but it is maintaining the pressure and flow from this well to reaching or matching with the manifold pressure. Another purpose of choke valve is to control the pressure from the reservoir and regulate the downstream pressure. See, downstream pressure, many wells are flowing to the production system. So when the manifold, all wells pressure to be equal or stabilize, in that case, that's why choke valve is arranging or closing or open more according to maintain the same pressure, flow, pressure, and stability of the hydrocarbon fluids. So allow fluid flow through a very small opening designed to control the reservoir pressure while regulating well production. So we can control the well production also, even 100% or 50% or 25%, we can control the production in quantity wise. The pipeline that carry oil and gas produced from the wells to the production processing facility are known as flow lane. So flow lane is after the choke valve, or you can start from here also. There is nothing wrong for that one. So better to, after choke valve, the flow lane is starting to production header, or it is going to further processing. So flow lane is a long distance pipeline arrangement which is connecting to wellhead to production header or manifold or gathering center. That is a simple definition of flow lane. So the pipeline that carry oil and gas produced from the wells to the production processing facility are known as flow lane and collectively form from the field gathering system. A well's flow lane start at the connecting flange to the wing valve. So you can better to say wing valve here. End at the connecting flange to deliver a diverter valve at the production or test manifold. So a flow lane is starting from the wing valve to manifold. That is the flow lane. See you can see here well number 1, 2, 3. Flow lane is there. Then again gathering station. Then again flow lanes are there. So why? Because individual wells are coming here with small quantity of oil. So one mini station can collect it and make it is a large quantity. So from other stations are also same concept. In small or gas field, small oil or gas field, flow lines are typically serve one wellhead or two. Flow lines carry the fluid or gas from the wellhead to manifold, from there flow directed to fluid processing system. So from flow lane is the connecting well to gathering center or CPF, central processing facility. And now the manifold, this is the manifold and other headers we can discuss. Gathering via manifold are most common solution where there are numerous wells or they widely dispersed. See, number of wells, normally 10 to 15 or 15 or 50 up to 50 wells are connected to a manifold according to their pressure and geographical arrangement. Nearby wells are individual wells are connected. See, all individual wells have a single its own flowing lane and connecting and entering to the manifold with the lane, and the well number will be there. Manifold is an important area facility to in early oil and gas production facility. So from there it is diverting to production facility, that is the core main production facility, or a test separator. Test separator we will discuss in detail later. Test separator is using to test the well behavior or well performance, or many other parameter also in doing that one. So in manifold is the important location to divert the dedicated well to either test separator or as general the bulk oil, the balanced bulk oil connected to production system. Normally one well is connected to test separator, rest complete the bulk oil connected to production system. The manifold package represents the part of the oil and gas treatment plant that gathers the production fluids from the well and divert it to the main line. The manifold is an arrangement of piping and or valves designed to combine, distribute, control and often monitor fluid flow. So you can say it is combined by individual fluids or a small quantity of fluid converting to bulk quantity, and distribute. You can distribute it to production gathering center or bulk oil separator. Control and often monitor fluid flow. You can monitor many parameters as well. Sample you can take from here. Flow lines from individual wells converge on one or two sides where the production fluids are blended. Such sites are referred as a satellite or gathering centers, and the location is chosen to minimize the flow line length from the wellhead. So in that case is mini manifold or mini gathering center will be there for the in various stations to minimize the flow line length. We call it as a satellite center. The manifold is an arrangement of valves and a collector pipe which allows individual wells to be routed according to their pressure to the appropriate separator system, HP and high pressure, intermediate pressure, low pressure or test. So it is an important facility or system in early production facility. And gathering center is this area we can call gathering center. Gathering center serve as a collection locator of the crude oil produced at several wells connected by the flow line, providing initial treatment through the separation of associated gas and water. So gathering center is the treatment starting area. Generally it is a high pressure or according to the pressure a separator or a series of separators connecting there to the first stage initial separation of gas, water and oil. They also provide an intermediate storage facility before the crude is pumped. So of course they can use as a intermediate storage facility. The line that join the manifold to separator are known as headers. These are called headers. From the manifold to production facility, the pipeline we call header. Chemical injection points are installed on individual header. So this location we are injecting generally chemicals to enable the injection of inhibitor and demulsifier. Normally two chemical corrosion inhibitor and de-emulsifier, because accelerating demulsifier is accelerating the better separation in short time, minimizing the resident time. So better separation and breaking the emulsion of oil and water. Of course, corrosion inhibitor preventing corrosion in the downstream side of this area after the manifold. This entire area, it is protecting from corrosion. This is to ensure efficient mixing before the separation process begin in the separation equipment. That is why the demulsifier and other chemical specialty chemical injecting here to maintain ensuring that proper mixing is taking place before reaching to production separator. Pressure indicators are also installed on the manifold and flow lanes for routine operational checks. There are several additional manifold and headers devices are follows. Another device are there. One is non-return valve here. Each manifold, each flow lane is just joining to the manifold. Here the manifold, we are keeping a check valve or non-return valve. These are fitted into individual flow lane to prevent the backflow from the manifold if there is a leak or burst in the flow lane. This will also prevent the backflow from high pressure well into lower pressure wells. The check valves should be as near to full bore as possible to prevent excessive pressure drop that would result in turbulence and possible erosion of the flow lane. Another one is a pressure relief valve. In the manifold, we are generally connecting a pressure relief valve, not only one, maybe more than that. A separate relief valve is fitted in each manifold and they are set to discharge automatically if the pressure is reaching to the manifold design pressure to protect the entire downstream area, and manifold itself we are keeping a relief valve, separate PSV pressure safety valve. The discharge is piped to the relief system and will continue as long as the abnormal high pressure exists. This valve will close automatically when the normal pressure is restored. Another one is ESD, emergency shutdown valve. Every manifold before starting to the production system, we are keeping a ESD for shut the well or shut the manifold and protect the downstream area and the manifold itself from in abnormal operation or abnormal situation like a fire or gas leak or any high pressure or low pressure or instrument system fail or various emergencies. An emergency shutdown valve ESDV is located in each header lane to automatically block the flow of the well fluid if a dangerous condition arises on the plant. ESDV is an actuated ball valve fitted to each header prior to the separator and will close on abnormal condition. Another one is sample point. Sample point are installed on individual flow line to enable well fluid sample to be gathered for analysis. So individual flow line or header also you can collect a sample. Then inlet separator, this is not a single piece of equipment, it's a number of equipments are connected in gathering center, processing facility starting. So before that also one SDV providing to prevent the downstream system in case upstream pressure is abnormal, upstream conditions are abnormal. All sections of a production systems are protected by an ESD system. The separator has the lowest working pressure of all the equipment on the production plant. This vessel is also protected against a high or high or a low oil level or pressure. Therefore, these conditions are included in the interlock systems of the ESD system. Thanks for watching this video. We will include more and more videos in coming sessions. Have a good day.